Hey everyone, welcome back to Pepcoding. So in this video, we are going to solve a new question, which is next greater element to the left. So what we are given here is we are given a number n representing the size of array A. Second, we are given n numbers representing elements of array A. What we are required to find is we have to require to find next greater element on the left for all elements of array. So what is next greater element on the left? Next greater element on the left of an element x is defined as the first element to left of x having value greater than x. We have to note one thing: if an element does not have any element on its left side greater than it, consider -1 as its next greater element on left. So this is an example. Let's analyze this example first. So we are given an array, this one. We have to make an answer array. What will be stored here? It will store those elements which are greater than that element on the left side. Like if we check for 1, it will check on left. It will check 3 first. So 3 is greater. 9 is also greater, but the first we have to return the first greater element to its left. So 3 is the first greater element. 3 will come here, right? So for 6, it will check the previous element. So 12 is greater. 12 will be the answer here. So 12, for 12 will check left. 1 is smaller, then we'll check 3 is smaller, 9 is also smaller, 5 is also smaller, 2 is also smaller. So it will return -1 as per the requirement of the question. So if we check for 7, 7 will check with 8, 8 is greater, 8 will be the answer. For 8, it will check with 6, 6 is smaller, then we'll check with 12, 12 is greater, 12 will be the answer here. So this is how we can do this question. Like, let's analyze this one more time. Okay, let's analyze this. We'll make an array ngl which will store its answers. Let's do it one more time. So let's do it from the starting index. So for 2, there is no element to its left, so it will return -1 in its answer. Now for 5, it will check with 2, so it is smaller, so it will also return -1. Now for 9, it will check with 5, 5 is smaller, then we'll check with 2, 2 is also smaller, so it will return -1. Next for 3, 3 will check with 9, 9 is greater, so 9 will come as the answer. For 1, 1 will check with 3, 3 is greater, so 3 will come for the answer of 1. 12, 12 will check with 1, 1 is smaller, then it will check with 3, 3 is also smaller, then it will check with 9, 9 is also smaller, then it will check with 5, it is also smaller, then it will check with 2, 2 is also smaller, so there is no element greater than 12, so it will return -1. Next 6, 6 will check with 12, 12 is greater, the answer will be 12. 8 will check for 6, 6 is smaller, then we'll check with 12, so 12 will be the answer here. Next 7 will check with 8, 8 is greater, 8 will be the answer. So we have to return this answer and we have to print this one. So this was the brute force approach. Like, what is the work done for 2? No element is checked for 2, so 0 work is done. What work is done for 5? It is checked only one element left to it, so only one work is done. For 9, 2, it is checked 2 elements, right? So 2 work is done. So this was the brute force approach in which we were checking each and every element to its left and we were returning the answer. So for the worst case scenario, if we can see, if we are given A less than B less than C less than D. So D will check for all the three values, like for C, then for B, then for A. So work done for D would be 3, right? So it is the worst case scenario. Like if we are checking for 12. 12 is checking for each and every element left to it. So it is doing so much work, and if this was the scenario, if the data was arranged in the ascending order, then our work done would be 0 plus 1 plus 2 plus all the elements till n minus 1. It will give the result as n into n minus 1, right, by 2. It will give the complexity of O of n square. So it is so much. How we can optimize this approach? Let's see. Okay. Let's see. 2, 5, 9, 1, 3, 3, 1, 12, right? 6, 8, 7. Erase this. It was 3, 1. So we are given this array. What we'll do, we'll take the help of a data structure which can grow dynamically and can store multiple values in it. Okay, in which we can add and remove values as per our requirements. So this was our answer array. What we will do is, for 2, it will push into the data structure. It will add from here, right? And it will push into the data structure and we'll check there was no element, so minus 1 was the answer and will push itself. Now for 5 will check with that element which is at the top of the data structure, so it is smaller, so answer is obtained minus 1 and will pop this out and push itself, right? So this one is removed from here. So adding and removing is going from the same direction. So it is popped out. 5 is there. Then we'll give the answer as minus 1. 9 will check with 5. If 5 is greater than, it is smaller. So what will it do? It will pop it out and 9 will come here. That's how the answer came. So what we are doing in this question in our optimized approach is, we have 2, it will check the leftmost, there is no element, so it is returning minus 1. 5 will check for 2 and will mark it, right? It will mark it and will return minus 1 because it is smaller than 5. Now 9 will check for 5 is smaller, mark it. Now it will not check for 2 because it is already marked by 5. So it will also return minus 1, right? Now for 3 it will check for 9. 9 will be the answer because 9 is greater than 3. For 1, okay, 3 is not marked yet. So 3 is not marked, but check with 9, answer came. 1 will check for 3. 3 is greater, answer will come. 12 will check with 1, mark it because it's smaller. Then we'll check with 3, mark it because it is smaller. Then we'll check with 9, mark it because it is smaller. There is no element which is greater than 12, so minus 1 will come as answer. Next, 6 will check with 12. 12 is greater, so of course it will turn an answer as 12. 8 will check with 6. It will mark it because it is smaller than 8. So now it will check with 12. 12 is greater. Answer will come. Next, 7 will check with 8. So 8 will be the answer. So this is the approach. We'll mark it. How we can mark it? Let's see. So we had this array 2, 5, 9, 3, 1, 12, 6, 8, 7. That data structure that I was talking about was a stack, right, in which we're storing multiple values as per our requirements. At last, right? So what we are having here is answer array, like NGL, whatever you want to take. So it will give -1 because there is no element left to it, and our stack is empty. So so 2 will push itself into the stack. 5 will check with the 2, the peak of the stack. If it is greater, then it will come as an answer. But if it is smaller, then pop this out, add 5 in the stack, -1 will come as answer. 9 will check with 5 if it is greater, but it is not. 5 is smaller than 9. Pop it out and push 9 into the stack. So which algorithm we are using is while what we are using, if our peak of the stack is less than array of I, then we are popping the element from the stack. And next what we are doing, we are pushing array of I into the answer, right? This is what we are doing. So let's do this while we are iterating to the array. So now it came to 3. So for 9, -1 will be the answer because there was no element greater to it on the left. 3 will check with the top of the peak of the stack. Array of I now is 3. It will check with 9. 9 is greater, then 9 will come as an answer, and answer will push array of I. So 3 will be pushed to answer the stack, right? Now for 1 will check with 3. 3 is greater, so 3 will be the answer, and 1 will push itself in the stack. Next 12 will check with the peak of the stack 1. It is smaller, so it will pop it out. Now it will check with 3. It is also smaller, it will also pop out. Now 12 will check with 9. It is also smaller, it will pop out, and 12 will come to the stack. Now 6 will check with 12, so the answer will be -1 for 12. 6 will check with 12, which is greater, then 12 will come here. 6 will also come in the stack. Next 8 will check with the peak of the stack, which is 6. So it is smaller, it will pop out, right? Then 8 will be pushed. 8 will check with 12. 12 is greater, 12 will be the answer, and 8 will push itself. Then 7 will check with the peak of the stack, which is 8. 8 is greater, 8 will be the answer. So this is how our approach works and this algorithm works in this question. So I think let's code it now, right? Okay, let's code it. So what we'll do first is int n equals to array dot size, right? Next we'll make a vector of type int ngl, size will be in comma 0. Next we'll make a stack of int type, give it the name as st. Next we'll start a loop for int I equals to 0, I less than n, I plus plus. We'll check the condition while st dot size is greater than 0 and st dot top is less than equal to array of I. Then what we'll do, st dot pop. Okay, next if st dot size is greater than 0, then ngl of I equals to st dot top, right? Else ngl of I will be -1, right? Next is st dot push array of I. Okay, and what we have to return ngl. Let's run this code and see if our code is correct or not. So accepted. Let's submit this code. So I hope I was clear with the concept, and thank you so much for watching this video. I'll see you in the next video. Don't forget to like, share and subscribe to our YouTube channel. Thank you so much.